Hello. So today's lesson should be a little bit more simple than the last couple. There's not really any new vocabulary. It's a little more easy to understand, hopefully. So we're talking about triangles and their angles and their lengths of their sides. So we kind of talked a little bit about this in the past. But when I have an angle, so like angle A, if I'm looking at angle A here, this angle is 20 degrees. And it kind of forms side C. Angle C over here is 70 degrees, so it goes out, is 70 degrees. So it kind of forms side AB. And then finally, AB is this angle. It's going to be 90 degrees because all these add up to 180 and these two are 90 together, so that has to be 90. And then that kind of forms AC. So if you look at the triangle, it's pretty easy to see that BC is the shortest side. And that's the reason that is because 20 degrees is the smallest angle and 20 degrees is the one that forms side BC. So what they want us to do in the first example here is to list the angles and then the sides from smallest to greatest. So angle A is the smallest angle, angle C is the second smallest angle, and then angle B. So this was 20 degrees, you don't have to write this on all these, but 20 degrees, 70 degrees, and 90. So then as far as the sides go, the opposite side of angle A is BC, so that's going to be the smallest side. The opposite side of angle C was AB, so that's the second smallest. The opposite side of angle B is AC, so that's the biggest or the third smallest. So that's pretty much all we have to do for these first few things. So number one, list the angles and sides from least to greatest. So the angles, well, first I gotta find angle M. So remember, all triangles always add up to how many degrees? So 180, hopefully you're saying to yourself. So if I add up all the angles, they should equal 180. So 122 plus 28 is 150. Subtract 150 on both sides, I get 30. So this is 30 degrees. So now it's pretty easy to see which angles go from smallest to greatest. So angle K is the smallest, angle M is the second smallest, and then angle L is the biggest one. And then I just got to figure out the side lengths. So angle K is the smallest angle. So the opposite side of angle K is going to be the smallest side. So that would be LM. Angle M is the second smallest. So the opposite side of angle M is KL. And then finally, angle L is the biggest. So the opposite side of angle L will be KM. So number two, this time they give us all the side lengths. So it's going to be the same thing, just doing it kind of in an opposite way. So it's really easy to figure out the side lengths. So 7 is obviously the smallest side length. So QR, the smallest side. QS is the second smallest. And then RS is the biggest one. So if QR is the smallest side, so QR is the smallest side, the angle that's opposite of that is angle S, so angle S has to be the smallest angle. And if you look, you can tell it's the skinniest one out of these three. QS is this side, whoops, not a good arrow there. So the opposite angle from QS was angle R, so that's the second smallest angle. And then finally, angle Q is going to be the biggest angle because it is the opposite of the biggest side. So that's the first page of the notes. Second page. This time we need to figure out side lengths of triangles. So there's this thing called the triangle inequality theorem. So that says that if we have 3 lengths of a triangle, if I choose any 2 of those, doesn't matter which 2, they have to add up to be greater than what the length of the third side is. So for example, if I go back to that last example, if I choose the two smallest sides, I add those up together, 10 plus 7 is 17. 17 is definitely bigger than 14, so that's why this can be a triangle. If I do 14 plus 10, 24 is definitely bigger than 7. 7 plus 14, 21 is definitely bigger than 10. So that is why they were able to make a triangle, because if you add any two of the sides, it has to be equal, it has to be bigger, than the third side. So it's asking for 1 through 4, can we construct a triangle given the side lengths? So what you need to do, you could add up all the combinations, but really you just need to look at the two smallest numbers. So in example 1, or number 1, if I add the two smallest numbers, 1 plus 2, that equals 3. Is 3 bigger than 3? No, it's not. So the answer to this would be no, because when I add the two smallest sides, they are not bigger than the third. So we cannot make a triangle with those lengths. So now if I take the two smallest numbers here, if I add those together, I get 7. Is 7 bigger than 5? Yes. So that means yes, we can make a triangle. If I add 5 plus 5, I get 10. Is 10 bigger than 10? No, it's not. They're equal. So one's not bigger than the other, so I could not make a triangle with those lengths. And then finally, 12 and 16 are the two smallest sides, so if I add those together, I get 28. Is 28 bigger than 25? Of course, yes it is. So the answer would be yes. So not too difficult. So now we need to find possible ranges. So in these examples, we know two of the lengths, and then we need to find what could possibly be that third length to make sure that the triangle inequality theorem still works. So that means if x is the biggest side, if I added 5 plus 7, that's 12. X would have to be less than 12. If x was not the biggest side, if I subtracted 7 minus 5, I get 2. So if I added x plus 2, excuse me, I don't want to add x plus 2, but 7 minus 5 is 2. So that means x can be in between 2 and 12. It cannot equal 2 or 12, so that's why I don't have that little equal sign there. X just has to be in between, anywhere in between 2 and 12. And no matter how you add any of the two sides, it'll always be greater than the third. So then, let's see screen. 14 minus 13 is equal to 1. 14 plus 13 is equal to 27, so that means x has to be in between. So x is greater than 1, x is less than 27. So that's how I say x is in between 1 and 27. Again, it cannot equal 1, cannot equal 27, but anywhere in between will be good. So let's say x is 2 in this example. So 2 and 13 would be the two smallest sides. So if I add 2 plus 13, that's 15. 15 is bigger than 14. Let's say x is 26, so one number less than 27. So that means these two would be the two smallest sides. So 13 plus 14 is 27. 27 is definitely bigger, than 26. So that's why this little formula works. So we're doing the same thing on these last few examples. So I recommend you pause the video and try to do these on your own. I'm going to do them real quick. So 4 plus 6 is 10. 6 minus 4 is 2. So x has to be greater than 2 and less than 10, or x is between 2 and 10. 14 minus 12 is 2. 14 plus 12 is 26. So that means x has to be in between 26 and 2. 5 plus 5 is 10. Oops. 5 minus 5 is 0. So that means x has to be in between 0 and 10. So notice it doesn't say equal to here. So this is still a possibility. X just has to be anything that's bigger than 0. So it could be like 0.1. or it could be a whole number. It could be 1, 2, 3. Just has to be in between 0 and 10. And then finally, 51 minus 34 is 17, and 51 plus, 34 is 85. So x would have to be in between 17 and 85. Box this answer up. And that's it.